Okay, guys, we're going to start doing special segments in triangles. It could be a little difficult. I think the most difficult part is probably matching the segments with their points of intersection, but we'll lead up to that. Let's start with just reviewing something and applying it to a triangle. So we're going to do perpendicular bisectors. Remember, perpendicular means you're going to need the negative reciprocal for the slope, and bisector, you're going to need a midpoint. So we need the midpoint of IR. The midpoint of IR is -3 plus 7 over 2, -8 plus -8 over 2. Well, that's 4 over 2, which is 2. -16 over 2 is -8. So that's the midpoint. 2 and -8. Well, IR is horizontal. So the slope of IR is 0, which is perpendicular to a slope of undefined. And undefined is just a vertical line. So we're just going to draw our vertical line here. Okay. And that's perpendicular. Here's my right angle, shows it's perpendicular. That one wasn't too bad. Now let's look at CR. So we need to find the midpoint of CR, right? So that's 1 plus 7 over 2. And that's 4 plus -8 over 2. That gives me 8 over 2, which is 4. -4 over 2, which is -2. So I have 1, 2, 3, 4, 1, 2. Well, now the slope is going to be a little bit more difficult. I got to find the slope of CR. Remember, that's the change in y over the change in x. So -8 minus 4, 7 minus 1, -12 over 6 is -2. So perpendicular to -2 is 1/2. So we just need the slope of CR. Then we have to find the perpendicular, 1/2. And just go from the midpoint. Up 1, right 2. Up 1, right 2. Up 1, right 2. I've run out of room. Instead of going up and right, I'm going to go down and left. Down and left. Down and left. Down and left. And I'm going to draw my perpendicular line through there. You guys would use a ruler. Right? You would use a ruler through this. Okay. And there's my perpendicular. So they're perpendicular. Lastly, I have CI. Well, CI is going to be 1 plus -3 over 2 and 4 plus -8 over 2. -2 over 2 is -1. -4 over 2 is -2. So there's my midpoint. -1, -2. I now need the slope of CI. I need the slope of CI. So it's a change in y, -8 minus 4. And -3 minus 1. -12 over -4 is 3, which is perpendicular to -1/3. So from here, I'm going to go -1/3. 1, 1, 2, 3, down 1, 1, 2, 3, down 1, 1, 2, 3, and I can go opposite 1, 1, 2, 3. And I'm going to draw my line. If we see here, we have a point of intersection. All 3 perpendicular bisectors intersect at this point here, which is 2 points of intersection is 2, -3. This point of intersection is called the circumcenter. Okay? So when you draw three perpendicular bisectors of a triangle, their point of intersection is called the circumcenter. Okay, it is called the circumcenter. I want to continue to learn more about this, but that is just point inside or on or outside of a triangle that is the intersection of three perpendicular bisectors. There's something true about this, right? There's something true about this. Okay. The equation, or actually, excuse me, not something true about this. There is, but we'll get to that. Here, it was very easy to see the point of intersection, right? It was very easy to see the point of intersection. Well, let's pretend it wasn't on an exact point. Let's say it was like right here. You'd have to find a way or need a way to solve this. Okay, so in order to do that, you're going to need a system. And we're going to do that right here. We're going to do that right here. Okay? And what we're going to do is we're going to find the equation of these three lines and show that if you do a system, right, if you do a system, you'll find the point of intersection. So if this slope here is 0, the perpendicular slope is going to be undefined, right? The perpendicular slope is going to be undefined. Okay. So this equation here is just going to be x equals 2. That's the equation of this, is x equals 2. Okay. And then this right here, I gave you the wrong one. We'll just fix that real quick. From CR, let's remember what was CR. The slope of CR was 1/2. Excuse me, the perpendicular was 1/2. So the slope was 2. So that means perpendicular, or -2, was 1/2. All right? So remember, this slope here was 1/2. So to find that equation, we take -2 is 1/2 times 4 plus b. Right? Remember, that's how we're finding the equation of the line. -2 is 2 plus b. B is -4. So I have y equals 1/2 x minus 4. If I look, 1, 2, 3, 4, that's where it is, 1, 2. Now, you only need the 2. You can get away with just doing 2, right? So I have x is 2. We already know that that's 2/3. Let's plug a 2 into here. Half of 2 is 1, minus 4 is -3. Look at that. 2, -3 is my answer. Okay? We're going to do the third one just for practice, but you only need to find the equation of 2. In practices, I'll probably tell you to find all 3, just so you're having to practice with it and you learn how to identify the easiest ones. But here, when you have a vertical or horizontal, use that one. That makes it real easy. Okay. So now, this is the perpendicular slope from CI is -1/3. This is my perpendicular. That's my perpendicular slope. So I have, right, -2 is -1/3 times -1 plus b. So I have -2 is 1/3 plus b. I'm going to subtract 1/3 from both sides. So b is -2 1/3. So I have y equals -1/3 x minus 2 1/3. Or you can write it as 7 1/3. Well, I don't want to have to use that, do I? That's why, let's pretend we did this one first, right? And I said, man, I don't want to mess around with this. Then I can go through and I can just do the next two and find it's real easy. But let's see. Do I get the same answer? Say x is 2. Say x is 2, right? Because we know x is 2. So I have -2/3 minus 7/3, right? Because if I plug a 2 in here, that becomes -2/3. Well, that just equals -9/3, which is -3. So that also works. But if it were me, I would choose the one without a fraction y-intercept. Here are the formal notes for the concurrency of perpendicular bisectors, which is just the circumcenter. Okay? So if I draw my perpendicular bisectors right here in red, they will intersect at a point. They will intersect at a point. And that point is the circumcenter. And that means because the circle is circumscribed about the triangle, right? So if I could put a circle perfectly around this triangle, intersecting each one of those, this point P would be the radius. The radius is equidistant from all parts of the circle. The circumcenter is also, right, equidistant from all vertices. Equidistant from all vertices. Right? The circumcenter is equidistant from all vertices. So this point here is the same distance from P, from B, from C, and from A. So a circumcenter, again, is the intersection of the three perpendicular bisectors. That circumcenter is equidistant from the vertices. It's coming from the sides, so it's equidistant to the vertices. Start understanding that, because when we get more of these, you're going to need that. It comes from the side, so it has to be equidistant from the vertices. Let's look back at our original problem, right? Here's our original problem P. This is our circumcenter. How can I prove, what would I need to prove that this point P is the same distance from all vertices? What would I need? Yep, that's correct. A good old distance formula. You don't need to watch me go through it, but I found the length of all three of these distances. I got 5 radical 2, 5 radical 2, 5 radical 2. So I found IP, RP, and CP. By finding all three of those, I've shown that they're all the same exact distance because the circumcenter is equidistant from all three vertices. Why are we using this, Mr. Bracco? This doesn't make any sense. Well, let's look at this. Here's a situation. Town planner wants to locate a new fire station, right? It's going to be a fire station. And it wants it equidistant from the elementary school, the high school, and the middle school. Why might that be important? So it can get to everyone in the same amount of time, right? So they have a strategy, they can get to everyone, like hopefully never ever happens, but if there were a fire, the fire truck can get to any of them in the same amount of time because it's going to be the same distance from all three of these points. How we would do that? We'd have to find the midpoint of here, so say whatever, here, and we would draw a perpendicular. In this case, we would use a protractor. Then we might find the midpoint of here, draw a perpendicular. The midpoint of here, draw a perpendicular. It would fall somewhere in there. This is the actual example of it. They only use 2 because remember, you only use 2. We're always going to do 3 to make sure you didn't make a mistake. Because if you only do 2 and you messed up on one of them, you won't get the answer. If you do all 3 of them, they will definitely intersect at the same place. If one line does not intersect the other 2, like so say I went here and I drew it there, we know that that is incorrect. That's incorrect, right? That's why we're going to draw 3. But the best place to put this is where I had it, about right here, okay? Because you're drawing the perpendicular bisectors to find the place equidistant to all 3. So that's where you would use it. A fire station, whatever, maybe a post office. You want to place something equidistant to all 3 things. As you notice, this one's outside the circle. Here are the 3 possibilities. If it's an acute triangle, it's inside the triangle. If you have a right triangle, it will fall on the triangle. An obtuse triangle will fall outside. Okay? This is useful to know as you can identify a triangle. Oh, it's an obtuse. My point is going to be outside. That's going to be it for this video. I'm going to post another one on the in-center. That's a very short video. We won't be able to do much on it because we're using protractors. But you have 2 students try. I want you to do these to the best of your ability. You can definitely draw the triangles, and you should be able to construct the perpendicular bisectors. So it's this, and there's one more video being